Hi, welcome back to the channel. We have something a little bit different today. We have here an identity that I thought was really interesting, and I used this on an integral recently, and I thought I'd go over the derivation for this. We have inverse tangent of x plus inverse cotangent of x equals pi over 2. Okay, what I want to do for my first step is, let's just focus on our arctan. What I'm going to do is, let's label this y. So we're going to have y equals arctan of x. Well, with this being an inverse, I can just rearrange this and write this as x equals tan of y. And then what I'll do is draw my right triangle in order to get a sense of this. So we'll just draw that. And of course, this will be 90 degrees right here. We'll have our angle as y. And then I can write this x as x over 1. So the ratio of our sides opposite of adjacent is going to be the same thing as x over 1. And then we could use the Pythagorean theorem to find our hypotenuse as x squared plus 1. You can just confirm that x squared plus 1 squared equals this hypotenuse squared. The nice thing about having the triangle is you can now find any of the trig functions, right? Like if we wanted to find the cosine of y, that's going to be just adjacent over hypotenuse. That would be 1 over x squared plus 1. So I think it might be interesting to find cotangent of y. Cotangent of y is adjacent over hypotenuse. That's going to be just 1 over x. If we take cotangent inverse on both sides, we end up with y equals cotangent of 1 over x. But notice we said earlier that y equals tan inverse of x. Well, if y equals arctan of x and y equals arc cotangent of 1 over x, then we can kind of just create a useful formula here that we can just say that arctan of x equals inverse cotangent 1 over x. This is a little bit of a detour, but I just wanted to capture this because I think it's interesting. Next, what I'm going to do is basically the same thing for our inverse cotangent. And what I'll do for this one is let's just call this one t. And we'll do basically the same thing. So we'll say t equals inverse cotangent of x. So then our x is going to be cotangent of t. And the thing here is we already have a triangle with an angle y, but we don't have any t. Well, what if I just make this other angle t? If we just look at cotangent of t, adjacent over opposite, we get x over 1, so that makes sense. We could look at tan of t. Tan of t is going to be opposite over adjacent, so that's going to be 1 over x. Doing the same thing before, we could take an arctan on both sides, and we find that tan equals arctan of 1 over x. But this is actually the same thing like we did here. T is inverse cotangent of x, and t is arctan of 1 over x. So I can just rewrite this and get another formula. And we can have inverse cotangent of x equals arctan of 1 over x. It's pretty nice so this is pretty good. We have a triangle, we've got our 3 sides, we've got all of our 3 angles. Now from here, what we know about a triangle is all 3 angles added together have to be equal to 180. So we're going to have y plus t plus this angle, which is just 90 right here, plus 90 equals 180. I can subtract 90 from both sides, and then we just have y plus t equals 90. But we know what y and t is. That's what we defined originally. So y plus t is just arctan plus arc cotangent of x, and this equals 90. And this is fine for degrees, but if we want to use radians, let's just write this as pi over 2, and that's going to match what we have here. And so inverse tangent of x plus inverse cotangent of x equals pi over 2. Anyway, I was thinking this is a really useful identity and kind of fun to prove it. So we'll stop it there. Thanks everyone for watching today. Please like and subscribe. Have a great day.